Hello friends, welcome back to Civil3D Pro Tips and Tricks YouTube channel. Today I'm going to show you how you can design 2D loop, how you can fix out the cross section of the loop and that nosing area, diverging and merging tapers. In last video we have seen how you can create alignment for the loop design, and we also have organized one live session. We have demonstrated how you can do your loop cross section, how you can draw the 2D design for the loop. Uh, so here the video for this in case you missed those live session. So let's get start with it. First thing, when you provide the interchange, well, interchange only need to provide when you have two major roads. Suppose you have two national highway crossing to each other, or you have two state highway or expressway or national highway. So in that case, you have to provide interchange because interchange is costly options. So it's only provided on the two major roads. Next thing that if the both road in urban scenario, if you have a two arterial road, major road where your speed or 80 or 100 kmph, then you also go for the interchange option. So this is so you need to keep in mind where you need to suggest or provide interchanges. Next thing, we're going to see how you can decide the loop radius. For the loop radius, first thing you need to check your site constraints. So for the loop, you can either go with the circular curve and you have to fix out some radius and you need to check whether this radius is uh, fitting in your site. I mean in your available ROW, or if you have any constraint here, like suppose any buildings or something. So you need to first fix out the loop radius. Loop radius generally start with the 80 meter up to 150. The larger this radius is good because the larger the radius, you get more length for the vertical design. So you can provide at least 5% or 6% grade if you have a more radius. If you have a tight radius, you should go up to the 7% or 8% radius. And also depending on your country standard, whether what is the maximum value allowed for the vertical grade for the loop. So you have to check that in your standards. So those are the things that you need to keep in mind while designing the loop radius. While selecting the loop radius, once you decided, okay, you have to go for 80, 130, then you have to fix out where exactly your nose will start. So roughly I have marked here that my curve 130 would be fit here. So my nose should be start from somewhere here or here. So once I started, I actually start to design. Second thing is that nose angle, or you can call it diversion or merging angle. So your slip road, or you can call loop, will be diverted between from main line between 3 to 5 degree. So it will be a smooth. So what you need to do, you need to roughly decide some point, and then you just select some lines, and you can need to rotate this between 3 to 5. So I'm rotating it to 3.5. Next thing that you can either provide a straight line for this diversion, or you can also provide a curve for the smooth diversion. So what I need to do, I'll just offset it to 1 meter, and this, and from here to point, I go with some higher radius. So why I'm going higher radius to begin with? Because I don't want any super elevation in my diverging area when I start to divert. You can provide supervision on actual loop, but you shouldn't need to be provide any super elevation where you are actually diverting unless you have any side constraint. So what I'll go, I start with the higher radius. I'm going with the 1050. Now the loop or any slip road, the diverging lanes, uh, the speed for that is less than the main line, so it should be either 70 kmph or 60 or 50 kmph. So your loop will be have that much speed. That also depending on what radius you are getting, what super elevation value you are getting. So you need to check the country standard again for that. So in begin with, you go with the highest radius. So I provided the one higher radius, so I don't need to provide superelevation when I'm start to diverting. Delete this. So temporarily I'm removing this my hard shoulder line, and so I created. The next thing is your nose area. Well, the nose area where up to this both roads are going in the parallel, or I mean in the same grade, and then you need to stop your restart your main line hard strip. So to this area there will be no hard strip or for the main line or the nose, and up to some point that you need to start your hard strip again. So that entire area called the nose area, where you provide some marking also, and that nose area should be, there are two values for that. Either you go with the 70 or 80 meter area, or you should go up to you get 1.1 to 2 meter gap between those two hard shoulder for the main line or the loop. The 70 or 80 meter I said based on the main line design, so you have to check your country standard that for 100 kmph what would be the uh, that nose area length. So you need to check that. I'm going right now here with the 70 or 80 meter. I'll go with the 70 meter. It should be somewhere here. Just extend it. Now my main line half strip is around 3 meter, and my loop half strip on the right side is around 1.2 meter. So this cross section is also you need to check your country standard, what is your loop cross section and what is your main line cross section. And up to this point I'll just delete this, and I'll just create one line here. So up to this point that actual hard strip will begin. Up to this area it will be all the main line area, and the grade will be 2.5 up to this area. From this it will start grading from 2.5 to the your super elevation. Now your loop section is also a bit wide because you are providing some tight radius. So you should have a wide lane. So if you are providing single lane, it should be around 4.5, 4.6 something. And this is just taking one of the standards. You also need to check again your standard, what would be the lane width for the single carriageway or for the dual carriageway. What would be the width for the your hard shoulder, left side or right side or earthen shoulder. So my left side is 1.2, my right side is 2 meter. And now up to here, you need to provide some divergent taper or diverging length. And that is depend your main line speed. So if my main line speed is 100 kmph, the diverging taper would be around 170 or 150. That's I'm saying depend from value from one of the standard. Again, you need to check your own standard. What would be a diverging taper length based on 100 kmph or whatever the speed of your main line. So I'm going with the 150 values. Here now you can provide different kind of arrangement. You can go with the diverge taper. You can go with the auxiliary lane, or in many cases, what people are doing, they generally go with the 3-lane road on the bridge section. Here, this diverging and merging sections. So you can provide a smooth bridge design. So either go with the diverging taper, auxiliary lane, or you can go with the three lane. But you need to make sure that you can provide a sufficient length between diverging and the merging. So one is diverging here, other loop will come from here and attach somewhere here. You should have to make sure that you have sufficient length between those two. And those depend on based on the traffic, what will be a would be your waving length. So right now we are just go with the diverge taper. So I'm just giving 150 meter diverging taper, and from this up to this diverging taper, your hash rate width would be similar to your main line. So I'm going with 3 meter hash rate or hard shoulder, deleting this, and whatever the difference between two hash rate would be tapered in this nose area. So my hard shoulder or hash rate 3 meter here and 2 meter here. So that tapering will be here happening in this area, into the nose area. So you can go either with the smooth tapering. I'm just tapering here. Alright. Now the same arrangement you have done in the diverge, the same arrangement you need to do on the merging area. But the merging standards are different from the diverging. I mean the merging length may need to be different from the diverging. So what we do now, we go and the process of creating nose will be similar. So you need to create a nose. Now I said either you go with the curvature or you go with the straight line. Here I'll go with the straight line. I again rotate this between 3 to 5. I'll go with the 3.5 value. And now I'll just provide curve between those two. So yeah, from here and here will be 130 kmph. Sorry, 130 radius. Just extend this, and delete. And just offset this. Like I get given 4 point and 2 meter. So as you can see already, and here is 1.2. Now in some case you have also earthen solder, is depending how you are designing, whether you are going uh, with the total RE wall, and you are going some point here with the uh, earthwork, or you are going completely with the RE wall. So you have to decide where you start with your earthen solder as well as some point where you start with your earthwork slopes as well. And the same thing will go for this also. At what point it will start with the earthen shoulder and earthwork slope. So right now I just finished my taper in my nose area, and this offset, uh, this also say 2 meter. So this is how you fix out your loop 2D with the diverging and merging. Now we fix out the merging. As I said, merging standard would be different from the diverging. I think I done some. It should be on third lane. Okay, it's right. And then again 4.6. From here it should be around 170 or 180 meter. Then again same thing here. Your main line would be a house holder 3 meter, and you need to see, now this case I will check when I get 1.2, at least 2 meter. So somewhere here, so I'll just delete this. So between both house strip, at least I get 1.2 meter gap. So just delete the rest of lines. This is your nose area done. The same thing I done like up to this point. Now it will be start 3 meter, and the tapering will be done in the nose area. And from this point it will be continue hard strip of 3 meter. So this is one kind of arrangement for the loop. What other you can do, you can go instead of this diverse taper. What happen many times people do, and they can go with the third lane here in this area. So up to this area it will be a 3 lane. You need to extend this and provide some taper from 3.5 to 4.6. And when this another loop will come up to this point, it will be a 3 lane. Suppose my another loop will come somewhere match here. So up to this section, it will be a 3 lane. Now this section also depend on the traffic and your waving lane, your diverging merging taper. You should at least provide 170 meter or 180 meter, whatever the your merging and diverging standard. So you should provide at least that lane between these 2 points. So this is also another option. Now another thing is to design the loop. Now you have to design some slip plane also. If you have in the slip plane, you again has to go with the same diverging and merging value. Everything will be the same. Your nose angle, your nose area, and everything will be the same arrangement. So that you need to start somewhere from here. Again start, and in that case, you can provide auxiliary lane instead of continuous lane or direct taper. You can go with the auxiliary lane of 170, and you can provide some direct taper, something like this. You can also provide an auxiliary lane as well. So, yep, this is the loop design or any slip road design, how you can divert your roads, what would be your cross section for the slip road or so in case you have a double lane, 2 lane slip road, it should be double the value. So right now for single lane it is around 150. For 2 lane you have to provide uh, auxiliary lane plus again the divergent taper. So when you have a 2 lane you have to provide double length, and in some cases the fork type of arrangement is also be done. So yeah, check your country standards and you will get more detail, more kind of arrangement you need to try. You need to see what kind of arrangement will be fixed on the particular situation. So this is just one simple loop design. Based on that, you can try all those complex loop design as well. So yeah, thank you for watching our videos.